Hi, good morning. I'm Jack Adjetey. I'm the MD for Reliance Fidelity International Group. I'm joined this morning by Lekki Oluwole, as Kafri introduced. Lekki is the General Manager for the Citigen District Energy Scheme for E.ON Energy UK. Can you flick the presentation on, please? Okay, so let's crack straight into it then. So like I said earlier, I'm Jack Adjetey. I'm the MD for Reliance Fidelity International Group. We specialize in energy technology and technical solutions, program and project management and continuous improvement, leadership coaching, as well as security risk, business continuity, and crisis management. So cracking straight into it then, what do we mean by sustainable technology? So sustainable technology really is one that creates sustainability by reducing environmental and ecological damage, one that considers natural resources and promotes economic and social development. So the sustainable technology example that we would cover for the next 20 minutes or so will be district energy. So in terms of district energy itself, we would look at how district energy is represented in, improved performance in buildings in line with the context of this scheme today. We'd also look at how we can optimize this for improved building performance as part of our operations and facilities management. We will then review a case study, a low carbon example of a live project that Lekki is responsible for. And then, finally, would like you all to join us in a conversation, a discussion forum actually on transitioning this to Africa and emerging markets. And if I could just, recap on what His Excellency, the Danish ambassador said, we need all hands on board to support transition. Okay then, so district energy. What do we mean by district energy? It's basically a network ensuring delivery of sustainable energy to the point of use. And this is done by connecting sources and resources to local requirements. So in line with rethinking operations management, we'd look at a few pros and cons of district energy. It helps us to meet our targets. It helps us to meet, government and organizational targets. There are so many policies and incentives around renewable energy and a whole green agenda. But are we signing up to those? And what are we doing, as professionals to ensure that we're meeting these requirements and targets? It helps us to recycle otherwise wasted energy. So byproducts from certain processes that we can harness to improve our performance and energy supply in some of our buildings. It is very efficient in highly populated areas. I was quite glad to hear the example before by the gentleman from GIS that highlighted a project at Kolibu, and that will become more apparent when we get to the discussion, because we identify that location as a good pilot site actually. It also helps to reduce the overall cost, and you might wonder why the capex can be quite high. But then if you look at it across the life cycle, it tends to actually reduce costs, as well as supporting policies. So what are some of the cons then? Like I mentioned before, the capital expenditure can be high, but it's always good to look at the benefits from a whole life cycle perspective. It's quite an unregulated area at the moment. So it's really nice to hear the honorable ministers talking about the Renewable Energy Act and other policies, using Ghana as an example, which would always help to regulate some of these technologies. The thing with district energy as well is you may buy into a long contract. So again, it plays hand in hand with the expensive capex and looking at it over the whole life cycle, because you'd sign up to an energy provider who utilizes district energy, and due to the centralization of the network, because you want to centralize production and connect it to the point of use, There may be long contracts associated with this. With some of the developments that Eon run and other energy companies, you buy a building or you lease a building, and your energy provider is set. So you all you can do is sort of incentives and processes and procedures to help you optimize that to your benefit. Operational issues as well can affect a large population because, like we said, it's highly efficient in highly populated areas. And overcoming this is purely by designing for resilience. So if a system, a part of the system goes down, you should have backup systems in operation to help you still maintain the performance of your energy requirements at the appropriate levels. And then obviously there's an argument of a skills gap, and that's not just in Africa and emerging markets. It's a global issue as well, because if I may use the term, sometimes people may not find it sexy enough, to jump on. So, publicizing these and ensuring training and incentives would boost and help bridge that skills gap. So let's look at how we can optimize energy for an improved building performance then. And we can do this by looking at looking at 4 key elements and their relationships. The first element is the people's aspect, and it looks at people, procedures, and capabilities. So competence, understanding requirements, and in terms of competence, are there suitably qualified and experienced personnel? Do we have sweat resources, who have the appropriate organizational culture aimed at optimizing energy and building performance? And do we have access to those people? Are they available? Or like I said, as a pro in the previous slide, there may be a skills gap there. Do they understand and do they practice these procedures? And if we look at, there's a South African saying, I'm sure some of our South African audience would recognize this, Ubuntu, which is, self through others. Having that, culture of togetherness and self-performance through others can help optimize energy for improved building performance, because it's that people's aspect. The second being performance, and this is, strongly linked with practices. It looks at quality. It looks at the availability and feasibility of the technology. And the issue of complexity comes into this, because normally we hear of green technologies or sustainable technologies, and we think of high costs, quite complex systems. But a lot of these technologies are actually based on very, very simple local solutions. So it has to be designed to scale, and it has to be feasible for the purpose. So it looks at quality, it looks at efficiency. And when we talk about efficiency as well, it's good to understand using data as a driver, using data to measure that performance and be able to optimize it where necessary. And also having the flexibility of your technical decisions, where you should design for resilience with enough redundancy. So performance is key when it comes to optimizing energy for improved building performance. The final one is policy, and we've spoken about policy quite a bit in some of the keynote addresses from the honourable ministers and His Excellency the Danish ambassador. It's really important to have stated aims, objectives, and strategies, because these underpin and define the state of the desired outcome, where we want to get to. It's good to have regulatory requirements and how we can be compliant and show compliance to those regulatory requirements, legal frameworks. And in terms of policy, regional cooperation is key. Regional cooperation doesn't necessarily have to be beyond borders, but if you look at, let's have an example, say schools or universities. Cooperation and legal frameworks that allows us to harness or replicate technology based on having a centralized generation point with a network can actually not only help optimize our building performance, it will help us reduce costs, because we're not designing from scratch for those particular users. We're just, replicating it and applying it elsewhere. And then finally, the final P is all to do with process. And this brings it all together because it enables people, it enables performance and policies, and it results in optimization. And that's, one way in which we can optimize energy for improved building performance. There are many ways, but we're just covering these few as a point of discussion. What we'll do next is Lecky will just share a case study using a low carbon example for site managers. All yours, Lecky.
Hi everyone. So what I'm talking about today is a site in London called Citygen. I'm currently actually sat at Citygen at the moment. It's located in the center of London, within the city of London, and it's surrounded by multiple sort of residential and commercial properties. Some names that you might be familiar with, such as the Barbican or the Guildhall or the Museum of London, usually they get their energy from Citygen. So it's a you can see at the bottom of the screen there are two pictures. So there's the Port of London Authority building, which is actually a building that was built in 1914, and there's the building on the right, which is named the cold storage, but it was actually a coal power station in 1894. So the history of this site goes from Victorian times to 2021. And in those periods, it's experienced a change in technology. So in 1894, it used to be a coal power station for the Smithfield Market, which is directly across the road. Smithfield Market being one of the largest meat markets in Europe. And then subsequently in 1995, the largest CHP plant in the UK was installed on the site, on the building towards your right-hand side. And in 2013, E.ON invested 23 million pounds on this site by installing larger and more efficient CHPs, which are combined heat and power. So in essence, what this building does is it provides low carbon energy for residential and commercial properties, and it creates the energy on site and transports the energy via a network of pipework, just as Jack showed in the slides before. And that's the beauty of district energy. And in 2021, currently we've invested another £4 million in a ground source heat pump. And a lot of you are probably very versed in what a ground source heat pump is. Basically, what we're doing is we're extracting water from the London aquifer at 14 degrees. We're stepping up the temperature to up to 80 degrees because some of the properties we're supplying are old and require higher heat. But then I'll just clarify that I know that we're talking about this in an African context. We provide heating, cooling, and private wire. So we also provide electricity. We call it district energy because it's technology agnostic. It doesn't really matter what's in the energy center. It could be chillers, it could be a ground source heat pump, it could be absorption chillers, it could be fuel cell, for example. The decentralized nature of it is such that because you have the network existing, all you're doing is you're able to adapt to your energy center, control the emissions at what point, and then transport that energy to your end customers. If you move on to the next slide, I'll show you what Citigen looks like. And as I talked about this solution, it's modular. So over the years, we have access to natural gas now, and we also have access to renewable energy from the ground. On the top left-hand side, you'd see the sort of gas main that comes into Citigen. Again, this is within a city center. So as some of you might be aware, this is London, this is central London, not on the outskirts. So we have to provide, we had a challenge of how do we decarbonize our current plant, which was one of the largest users of energy in London. How do we do that without adding more emissions into the atmosphere? And how do we not jeopardize the energy quality or the air quality within London? And that's what district energy allowed us to do, is the ability to chop and change, if you want to call it that way, and introduce technology. So very simply, what we do is we burn natural gas and in something called a CHP, which is combined heat and power, that can generate electricity and heat as a byproduct. We capture those, and we have gas boilers, which gives us that extra resilience, which Jack was saying, in terms of when you look at the network itself, how do you stop operational issues affecting multiple residents? We have Barbican Art Center, which is one of the sort of largest art centers in London. How do we ensure that we were able to provide comfort and still meet the end products? And now in 2021, we're installing 4 megawatts of heat pump. Again, this is literally groundbreaking. We're drilling 200 meters into the ground, extracting the energy and running it via heat pumps and providing heating and cooling to our customers in the network. So I'll give you an idea of what the network looks like on the next slide. And one thing I just wanted to mention is that the ability to tap into electricity and natural gas means that the future of Citigen is, I'd say, it's future proof, and it's certain, because if the gas grid decarbonizes, we have access to that. As the electricity grid decarbonizes, which has been doing for the last 5-6 years. I think there was a period in the UK where there was no coal being burnt. It was pretty much zero carbon, and that's what we can benefit from having district energy. And this is just the scale of the network. The network itself is 11 kilometers of pipework underground in London, through tunnels and car parks. And then one thing I just wanted to clarify is that this is only possible via collaboration. It's not possible to do this alone as a private company. It's not possible to do this alone as a public entity. You need to be able to join the public and the private sectors to come in hand with the right policies, and to basically allow for investors to have belief in the system, and to have, I say, trust that when they invest in such technologies, they would have the policies in place that will enable it to grow. And this is just, as I said, 11 kilometers of pipework going all around central London, and we are connecting more customers. My job is to ensure that we stay on track and to decarbonize this energy plant, and to grow it. So not just within where we are, but to grow into different boroughs and different aspects of energy. So that's it for me. Thank you.
Thanks, Lecky. It's quite a good point to mention as well. Citigen has been on various documentaries, and Lecky is actually in the middle of filming with the BBC. So once we get the link for that, we'll share it via Yecham. So this is where we invite you all to participate in the discussion. The discussion really on transitioning to Africa. And like I mentioned, what His Excellency, the Danish ambassador, said, we need all hands on board to succeed. So you can join the discussion, you can ask questions, and I'm sure the moderator would allow that. So we can all talk about it as a collective with SDG 7 and 11 in mind, as with in line with the outcomes of this summit, really. So just to recap on SDG 7 and 11 is basically affordable, reliable and sustainable energy for all, as well as sustainable, safe and resilient settlements. And like I mentioned before, there's a photo of the University of Ghana there, and a map of Kolebu Teaching Hospital. And it's just to highlight how important district energy is, how efficient district energy is in highly populated areas, such as these two examples. We can discuss transitioning through smart, local, and sustainable solutions. We've mentioned policy, the people's aspect through training, access to finance, and regional cooperation. And before I hand over to the moderator to open a channel so we can have a very short discussion on it before the next presentation, I'll just mention an example of transitioning that I experienced myself in Kenya. Actually, if there are any Kenyan participants online, they'll probably recognize this area. When you're driving through Kenya on the Thika Road, right in front of Jomo Kenyatta University towards Nanyuki, towards Nanyuki. I was in Kenya on a project somewhere around the Nanyuki area. We're designing and building a facility there that would accommodate about 1,500 people up to about 4 times a year. So it's not manned throughout the year. So there's a need to design for very, very low maintenance and, put it in sustainable systems that are not too maintenance intensive. Now, we had a solution for heating and comfort cooling, and that's when we're driving up that thicker road. It just became apparent that you look to your left and your right, and almost every building you see as you're heading out of Nairobi would have one thing on top of it, a solar water heating system. There were bigger buildings with bigger networks, and there were smaller buildings with smaller networks. And we had a rethink as we were driving up on this recce to put a design in place to use a local solution, because what they had at the time was incentives for local manufacture rather than importation of these systems. And that promoted training, it promoted and created jobs, and they also promoted actually transitioning a sustainable solution that may be expensive and utilized elsewhere in the world to a location in Africa where the source, which was the sun, was readily available. So off we went and designed a system using a locally manufactured solar water. Well, we had a number of solar water heaters, and we actually connected them via network to the ablution blocks for the accommodation blocks we've designed. And we also harnessed the heat from comfort cooling to provide a backup heating system for times where there may not be enough coverage for the solar collectors. So on that note, please, your ideas in terms of transitioning to Africa. Any discussion points, please?
Well, first of all, I want to say thank you to you, Jack and Leke, for the presentation on the sustainable technologies case of transitioning to Africa and emerging markets. And